Recording. Okay, so we are recording just through OBS, not through Teams. That's why you don't see the. Actually, well, we might be doing both, but at least this way I can capture the whiteboard. Okay, so today we will go through the assignment 1. And so there were 2 questions. Got the text of the first one on here. A design team writes down as one of their requirements that the software component S shall fail no more than one time every 1 million runs. Subpart A, given that every run lasts 20 minutes, calculate the failure rate of software component S in failures per hour. Show your work. And so, back when I took physics, one of the first tricks I learned is, if you know what the output unit you want is, what the units of your inputs are, you can at least make sure you're getting there. So we know we want, failures per hour. And we know we've got a failure rate of 1 failure per million runs. And we know 1 run takes 20 minutes. So runs will cancel out. So now we've got 1 failure per 20 times 10 to the 6 minutes. We want in hours. So we know there are 60 minutes. It is not like my handwriting. Per hour. So minutes cancel. So now we know we've got 60 failures per 20 times 10 to the 6th hours. We can do some little canceling here. And so we've got 3 failures per 10 to the 6th hours. We divide that by 3. You end up with 1/3 10 to the 6th. So what's that? It's like 3.3 10 to the. Oh, and you're going to put this on top. So let's. So you end up with something like. How do we want to do this? We want to if we got times 10 to the negative 6th. Failures per hour. So I think that did I do that right? Where's my double check my key before I give you guys bad information. So so failures per hour, you end up with something like 3 times 10 to the negative 6 failures per hour. So obviously you wouldn't want it to fail much in a given hour, so you want a small number. So that's pretty decent. Is there a way to easily clear that so I can go into part B? Should have left myself more space. I don't know if I want to zoom out like that, but that's still legible. Can we pan over? Is there a way to? Yes. Okay, that's pretty intuitive. Okay, so if we know that the previous answer was we have 3 times 10 to the negative 6th failures per hour, then given the above failure rate, determine the mean times between failures. So if we have 3 times 10 to the negative 6th failures per hour, 1 over 3 times 10 to the negative 6th is the number of hours per failure. And so I didn't give you a unit for how much time is on there. So, so 1 over 3 times 10 to the negative 6th is something like, 1/3 times 10 to the 6th, so that's 1/3 of a million hours. So that's, a lot of hours. So if you put it in hours, hopefully she gave you full credit. If you convert it to years, because that's, years worth of time. If I brought up my calculator, you guys couldn't see it, but it would be in the video. So I know what, because I'm capturing a window, not my entire screen. So hours is fine. I trust you can do the math to get, so 24 hours in a day, 365 days in a year, so still lots of hours. Like 50 years or something like that. I don't have the exact number in front of me. Describe any problems one could have by writing down a requirement like the one above. Since this is like a soft, so there's, not just one right answer, so this was the greater sort of discretion. But the big one would be, if you have a system where you're saying it should fail like once every 50 years, the naive test would imply that it took 50 years to test to make sure that that was right, assuming you didn't get lucky and it lasted longer, unlucky and it lasted shorter. So very hard to test a software requirement like that. If it were hardware, then we could find the mean time to failure of the subcomponents that may have been tested and then do some statistical methods. But for software, that is a really hard, requirement to test. And so the failure rate, really must be achieved by some sort of robust design and implementation of the software, and extensive testing. But telling someone to make you a software program that fails once every 50 years, not really a useful requirement. Okay. Problem 2. Best way to do this. So if I copy and paste without the diagram, probably, well, maybe. Let's see if the diagram copies and pastes. Copy, paste, paste. Oops. I want to move this, not the whiteboard. Well, we're just going to start over. Okay, we don't get the picture of the diagram on here, but you all have the assignment. And the equations are pictures too. They don't copy and paste. Okay, so I'll rewrite that on there real quick. Come on. Why are you doing that? Okay, stop that. Do not know why that's panning. Maybe I've got the control of the Alt button locked. Nope. Okay, that's annoying. So I'll just type it. Okay. I want to tilt it. There we go. Okay, we're going to say T1 equals, grab the sheet, 0 seconds. If I tab out, it goes away. T2 equals, what did I say, 15 milliseconds. T3 equals 50 milliseconds. Okay, still don't know why the entire thing's moving. Okay, I guess I keep typing because it doesn't want to let me draw. Okay, so determine the minimum sample rate which you need to sample the sensor. So I'm going to assume you can see the diagram on your copy of the assignment. You want to sample based on the rise time. So that's the difference between T3 and T2, which is 50 minus 15 milliseconds, which is 35 milliseconds. If you did it based off of the time all the way back to T1 instead of T2, you shouldn't get points on part A, but then if you use that value on part B, you should still get, you shouldn't lose points twice. So if that happened, point that out to the TA and hopefully she'll fix your grade. But that's the rise time. So that's rise time. Make this longer. And then, so if you recall from the notes, since this is a like static signal or whatever, as opposed to a periodic signal, you can't just use the Nyquist criterion for like 2x. Specific call out in the notes, you should use 10x for this, which means 35 divided by 10 equals 3.5 milliseconds is how often you should sample. But it says sample rate, so that should be in hertz, or 1 divided by 3.5 milliseconds, which is 1 divided by 3.5 times 10 to the negative third seconds, which in hertz is, where's my calculator? So that looks like that should be something like 286 hertz. So you should get something like that for your answer for part A. And then for part B, guessing this still isn't working. Nope. So we'll do another text box. Lost the text box. Try this again. Okay, part B. Suppose the computer must make some computations after each sensor readout. What is constraint the duration of the computation? So sort of two ways to get that. One that might be obvious is to just take 1 over the sample rate, which gives you back this number, or maybe you just got this number directly. And so either way, 1 over 286 hertz is 3.5 milliseconds. So that's just the answer. You go back to 3.5 milliseconds is your answer. How do I move this? Okay. I may or may not use the whiteboard next week. I thought it would be a good idea, but I'm not liking it. Part C. What is part C? What is meant by the dead time of the system? So like I said on the review session, you can either describe that in words or in an equation. Equationally, the dead time is the computational time plus the object time. So if you just wrote something like that, that should be enough for full marks in that question. If you wrote it out in words, that should get you credit too. And that is it for assignment 1 and 2. So I'm sorry if it wasn't incredibly clear on the blackboard. I need to either practice this or find a better way to communicate some of this stuff. So I'll open up the floor to questions now for people that may not have understood what is going on here. I mean, this was a fairly easy assignment, but if something's confusing, let me know, and I'll take questions now. Any questions? Or did everyone here get a 10 out of 10 on the assignment? And just showing up to be a dutiful student? Or understands their mistakes now that I've explained the answers?
Where would I find this equation for the sample time or the sample rate?
Okay. Yeah. Let me see if I can pull up the slides. I should be able to find that pretty quick.
Yeah, I looked it up in the slides, and it was like some one or 0.1 times something.
Yeah. So I think it's 0.1 times the rise time, and so I get the extra slides. Okay, so I'll stop sharing the Blackboard now. And how do I just switch to sharing my slides? Okay, so let's find, assuming I'm on the right, I think I'm on the right one. Is it? No, that's not it yet. Okay, yeah, so sample time has to be less than, the rise time. So technically, like everything where I said like 3.5 milliseconds should be 3.5 minus epsilon milliseconds. It should be slightly less than the rise time. But so then to actually see like what, so the rise time, is the amount of time it takes to go from a low state to a high state. And so, let's see, rise time of physical constraints of the system. So basically it's the time you go from, the low state to the high state. So if we actually go to if I share the assignment, if I can share that now, stop sharing, share, the assignment, from this picture, maybe you would infer that it's actually slightly after T2 and slightly higher, but I said not to scale, so you can really only use the time points. But if you picked these times as opposed to these times, and explain that in your work, you should probably get points for that too. But yeah, the rise time is basically T3 minus T2. If you went to like T3 minus T1, I guess T1 was 1 millisecond, not 0. But if you went from T3 minus T1, that's T1 is sort of when you issue the command. Then T2 to T1 is sort of that computational time where it needs to figure out what it needs to do. And then T3 minus T2 is basically the object time where it actually takes time to open that valve up. So it's the rise time, here between the signal is the one you've got to do your sample rate based off of, not the entire.
Yeah, I made the mistake. I forgot our computation time, so I was like, when they added the voltage to the
yeah. If you go back all the way to T1, yeah, then you would you should maybe lose some points on like part A, but you should still get credit for like if you use the number you got from part A in your part B answer, and you took off points twice. I don't like errors to sort of accumulate in the grade, so let the TA know, and she'll probably give you some points back. But yeah, part A should just be 3 minus 2, not 3 minus 1. Good question. Any other questions? Is there a chat? What techniques are used to prove requirements with long? Yeah, we're gonna talk a little bit, probably about week 5, for some statistical methods on failure rates. Hopefully, I think stats isn't a formal prerequisite for this class, but it'll help a lot if you've taken that, because there's a lot of, depending on if your system is set up like with the components in parallel versus in series and stuff like that, those sort of things matter, fault tolerance reasons. So yeah, we will talk about that in detail for like 1 or 2 weeks later in the semester. Any other questions? Okay, so I think that's probably going to be about it for this then. Like I said, next week we probably won't have too many questions because a lot of it's a writing assignment. So I'm hoping to have some content made for helping people that without much programming experience, you know, figure out how to actually like do plots in Python and MATLAB and stuff like that. So if you know you're going to need that, tune in on Tuesday and Thursday. Hopefully I'll have that done. So if there aren't any other questions, that'll be it for today. If you want to review this recording, I don't think Teams captured any of the whiteboard stuff, so you'll have to look at my OBS recording that'll be on the YouTube channel. The recording inside Teams won't have any of the whiteboard, probably. So, but if there's no other questions, you are all free to go.